Background: QualNet is a commercial version of GloboSim used by Scalable Network Technology for the defense projects. The various tool performance simulations on live engagements, which might be either war games or actual battlefields. The GloboSim, that is nothing but the Global Mobile Information System Simulator, is a network protocol simulator software that simulates wired and wireless network systems. Designing of the new protocols and optimization of the new models was very difficult in GloboSim, which gave rise to the new quality network called the QualNet. Let's start comparing the few network simulators which are right now being used by many users. The few are the OpNet, the OMNet, the NS2, the QualNet and the JSON. The QualNet language is nothing but the parse C++, OMNet has C++, NS2 has OTCL, and JSON has Java. The license is commercial for QualNet and for OpNet. The others are open sources. Though it is commercial, it is more easy to use because the OTCL script and the JavaScript are a little difficult to learn. C++ just takes hardly time. Then the GUI support for QualNet is very good. The user interface is very excellent in this compared to the OMNet, the NS2 and the OpNet, because usage of that is little difficult. Learning the tool takes very less time. 2 weeks is more than enough to learn the QualNet as a whole. OMNet and NS2, it takes a long time because of the languages used by them for us to learn. Platform, it can either be Linux or Windows. For QualNet, it will work on both. The others have Macs, their moderate software and the MATLABs. It takes time to learn how the users actually use those labs for particular features. And then availability of the analyzation tool, the networks visualization tool, the possibility of designing the modifying the scenarios, creating trace files and interacting with them, all are more very good in QualNet because of the user guides given by the QualNet once you download it in proper website. So with these features, QualNet is comparatively better and the most user credential tool in right now scenarios. Coming to the introduction, we have various versions in QualNet. It started off with 4.5, 4.5.1, 5.0, which ended up with 6.1, and the present version is 7.1, the latest version. There were a few features added to it. In the new features, the first one was the multimedia and enterprise model libraries, the developer model library, the wireless model libraries, and the federation interface libraries. There were a few standard model libraries also being added. That is nothing but the standard interface model libraries and the satellite model libraries. There was a library called the TIREM model library, which was discontinued from 6.1 because that was of no major use. There are a few bugs fixed from the 6.1 version. That 1's version GUI was not that great. Here it's been developed. It's been more user-friendly for us. The developer model libraries have been added. The wireless model libraries have been fixed. The few layers like the MAC layer, the physical layer has been improved to make it more user credential, and then you have the antenna models and the statistical databases have been increased. 7.1 version among all the versions have the best planning and testing and the training tool that mimics the communication of the real world network scenarios.
Everyone, my name is Amrithik. I am from MSRIT. I am going to explain benefits and architecture of QualNet.
So here comes with features and the benefits. The key features of QualNet that enables in creating the virtual network environment are: this comes with speed. It's a real-time possible in the QualNet by enabling the software in the loop and hardware in the loop modeling. Next comes is scalability. The scalability can model thousands of nodes by taking the advantage of latest hardware and the parallel computing techniques. The next comes with the model fidelity. It uses a highly detailed standard-based implementation protocol model. The next comes is the portability. It can have thousands of library on the vast array of platform, which includes Windows and Linux operating system. The last comes here is extensibility. It can connect to other hardware and the software applications for the greatly enhance the value of hardware model. Let's see the benefits of the QualNet. The QualNet enables the user, helps to design a new protocol model. Next, optimize a new and existing model, and helps also to design large wired and wireless networks using pre-configured or user design models as shown in the diagram. The final one is it helps to analyze the performance of the network and the performs what if analyzed to optimize them. Then next comes with the installation process. The link is given for downloading is that qualnet.software.info.com for QualNet version 7.1. It downloads for it takes a time to install.
Once you download the zip file from the net, go to the folder containing QualNet Windows Installer.exe, double click on it. There will be a pop-up message to go ahead, so click on yes. You'll get a window telling do you want to install QualNet, so click on next. This is the license agreement. Scroll down, read through it, and then click I accept the agreement, and then click on next. There is additional readme information provided by QualNet, so read it and then click on next. Here the QualNet folder will be stored, so you can even change it by browsing. So after selecting the folder, click on next. These are all the various things that will be installed in the QualNet folder. So click on install. It will take around 15 minutes to install the complete package. Once that is done, you will get the QualNet GUI.
Here we go with the architecture of QualNet. So it's divided into the form of layered architecture. First comes with stimulation kernel. It's a kernel of QualNet. It's a parallel discrete event scheduler. It provides scalability and probability to run hundreds and thousands of nodes with high fidelity models on the variety of platforms, from the laptops and the PC to high performance computing systems. Users don't interact directly with the kernel, but uses QualNet API to develop their protocol model, as we see in the Android APIs. The next comes is model libraries. A model library, it helps to support the number of model libraries that enables you to design a network using the various protocol models like AODV protocol, Bellman-Ford protocol, etc. And it also includes the developer and multimedia and multimedia and interface and wireless model libraries. We have an additional libraries to model the cellular networks, satellite networks, UMTS networks, WiMAX networks, sensor networks, etc. The next comes is graphical user interface. Consists of 4 graphical user interface. It's architecture, analyzer, packet tracer, file editor. Architecture has 2 types. It's the design mode and with visualize mode. Design mode helps to design for a terrain, network connection, subnet, mobility patterns of wireless, and helps to create a new network using click and drop options. Next, visualize mode, in-depth visualization and analysis of nectar scenario. Next comes is analyzer. It is a statistical graphing tool that helps to display the hundreds of thousand metrics collected during the simulation of scenario. Next comes with a packet tracer that provides a visual representation of packet trace while generated using the simulation. And finally, the last comes with the file editor. It's an editing tool that displays the content of selected file in the text format. So next comes is a command line interface. It enables the user to run a QualNet from a DOS prompt or from a command window. QualNet running from command line, its input to the QualNet is in the form of text file. Building and running a scenario with CLI takes less memory and runs faster than GUI. So here we'll explain about the basics of the QualNet. Let's explain the basics of the QualNet. It's a file, edit, view, tool, animation helps. Next, architecture, analyzer, packet tracer, file editor, file menu. The file you can open, it helps to create a new file, and open files, it helps to open a new file, and a recent file, which helps to open a recently opened file, closes the current scenario. And next you can save the file. Next, page setups helps to set up in a layout. Next, print, you can print the scenario. Next, exit comes out from the QualNet. Next, edit, in which you have an option cut. You can cut the selected objects. If an object is cut, all links attached to it are deleted. If both ends of the links are cut along the links can be cut and recreated on the page. Next, copy, you can copy the selected object. A link can be copied only if the objects that connects are also copied. Next, paste. A paste or previously cut or copied object. Deletes the selected object. Selects all the objects. Preferences, in this you have a text editor and the port. Next, you have a view menu. You have 4 type of toolbars: standard toolbar, view toolbar, run toolbar, visualization toolbar. Here we comes with standard toolbar. controls whether the standard toolbar is displayed or no. Next, view toolbar controls whether the toolbar is displayed or not. Controls the run toolbar, it's displayed or no. Controls the visualization toolbar or not. Next is a zoom in or zoom out option. Next tool, you have a tool option. Next tool menu. In this, you have a node placement, a view scenario in file editor, run settings, run stimulation, device model, hierarchy model editor, toolset editor, multicast editor, group editor, antenna model editor, modified parameter, weather properties, scenario properties. In this you have node placement. Node placement, you can launches the node placement wizard, which is used for automatic node placement. Next you have view scenario in file editor, opens the scenario configuration in the text editor. Run settings helps to open the run editor, which is used to specify the number of processor while running the simulation. Next, run simulation used to initialize the live simulation on the active scenario. Next, records animation used to run the active scenario record and record the animation trace in a file either interactively or non-interactively. Device mode editor launches the device mode editor using which you can create a custom network type and device type models. Next comes is a hierarchy editor. Launches hierarchy model editor using which you can create a custom hierarchy models. Next you have a toolset editor. Launches the toolset editor using which you can modify the standard toolset and create new toolset. Next, antenna model editor. You can launch the antenna model tool, which is used to import, create and modify the antenna models. Next, weather properties. Launches the weather properties used to configure weather pattern properties. Next comes is animation. Here you have animation color. It helps to create a new scenario. Next, it helps to open a recent file. Next, it helps to save the file. Next, it helps to print a file. And this icon is used to cut the file. Next, this icon is used to copy the object. This icon is used to paste the object. This icon is used to delete the object. Next, you have select icon, which is used to select an object. Next, lasso tool icon is used to select multiple objects in a scenario simultaneously. Next, you have a pan, which is used to move the scenario display in the central workspace. Next, rotate 3D, you can rotate in a three-dimensional view. Next, you have zoom in or zoom out option. 4 types of view: XY view, YZ view, XZ view, 3D view, split screen. Next, you have a reset view. You can it goes by default view. Next comes with the saved view. Saved views is a button used to switch between different views of scenario. Next, overview. The overview button provides a prominent way to quickly change the camera position from one position to other. Next, you have a run toolbar. It helps to open the current scenario in file editor. Next, you have a run settings. Run settings is used to specify the number of processors used for running the simulation. Next, run stimulation is used to initialize a live stimulation for active scenario. Run stimulation is used to run the current scenario. Next, you have visualization tools, which is used to play the scenario. Next, it is step mode is used to know the step-by-step process. Next, you have a stop icon to stop the tool. Next comes with the standard tool set. Devices, contains a button for basic devices, which includes a default device, which is nothing but a node. Next, you have a ATM device. Next, you have a switch, and next you have a ground station. Next comes with an UTMC device. Contains a UTMS devices like UTMS RNS. Next, UTMS node B, and etc. Next comes with applications. Contains a bar for server client applications configured using the node ID and IP address. It contains CBR, cellular, FTP, FTP gen, GSM, etc. Next, you have a dynamic address application. Contains for server client applications that are configured using fully qualified domain name of the server or a destination node. Next, you have a single host applications. Contains a single host application. It where the traffic is sent to the multicast or a broadcast address using the HTTP, HTTPD and etc. links. It contains two types of links, BGP link and normal link. Links are used to create wired or a wireless links between the nodes. This is a normal link used to create a normal link. This is a wireless link used to create for a wireless. Next you have a network component. It contains a buttons for hierarchy. Next it contains for a constraint hierarchy, hub and wireless, and even for the satellite components. Next you have other components like weather effects, next for mobility and for the node. Next comes with the visualization control. It has, you have two stimulation time, and you have a real time and animation speed, and you have animation filters. It provides a stimulation status like time, speed and progress, and displays the event, and the layer filters can be applied to the animation. Next, runtime analyze displays the properties of nodes, queues and subnet from this panel. So next comes with the canvas. This is the outer layer of the canvas where you have x, y, z positions. X, Y, Z, you can specify the X position, you can specify the position of Y, and you can specify the Z position. Next comes with a bottom toolbar. You have a table view where you have nodes, groups, interface, networks, applications and hierarchies. Output window prints a standard output which is redirected to the output window. Next, error log displays any error messages. Next, you have a watch variable. You can watch the values of dynamic variables during simulations. Next comes a batch experiment used to configure batch experiment.
Hello, I'm Manisha. I'm studying in MSRIT. Today in this video, I'll be talking about the GUI and the properties related to the scenarios created in the QualNet. So let's go for it.
Let's start off by creating a scenario. I'll open one which has already been created. Recent files, open. This is how you open it. The devices which have been present in the canvas area have been put from the standard toolset here. So you have the default devices, you have your switch, you have your hub, you have your different ATMs present here. This is the wireless network. You have the wirenet subnet here, and this is the links for the wirenet. This is the ATM which is linked by a wired, and then this is your hub, this is your switch. So this is all being placed from the standard toolbar. So let us start off with the scenario properties. So in the scenario properties, you have general. In general, it has parameters like experiment name, experiment comment and all. These experiments can be changed to something which is more desirable, like sample. Comment can be set if you want. Simulation time is not 30 seconds. In 30 seconds nothing can be seen, so it is usually set for more than 200 seconds. Here I'm taking it for 300. The seed time is 1, and you have your scenario background image that can be set to anything. This can be optional if you want, otherwise you can go to the array editor and select one from any of the icons present here, and then you can apply OK. Let's go to the parallel settings. Parallel settings basically is used for parameters for parallel simulation that can be set via the schema here, automatic or manual. So that can be according to the scenario. Then you have preferred memory. Then you have the advanced settings, which is used for configuring the parameters for dynamic command configuration and event queue type. So that also can be set here accordingly. Then you have your terrain. In terrain, you have the tab specifying for the coordinate systems that can be either Cartesian or latitude, longitude. So that depends on the scenario again. So Cartesian here, 1500 is the scenario dimensions. This is usually okay for your wired situations or scenarios. But if you want for wireless, you have to go for 100 by 100 because the range for wireless is that. It's actually 300, but 100 works in a better sense. Then you have your terrain data format and urban terrain format, which can be set again as Cartesian or none. As for this, as QualNet format. And this has a terrain file, you have to shapefile. Accordingly, it can be set. Then let's go to the channel properties. Channel properties, basically it's for configuring the channel properties such as frequency, path holes, fading and all that. That is be sent once you change this number of channels to 2 or 3. It can be set to anything. Changing that, you do apply and then go for the array editor. You have different channels here. So you have index 0, index 1. But if both the indexes have the same channel frequency, it can't be heard. It's like two people talking in the same pitch. No one can understand anything. So we change the frequency. For index 0, we leave it as 2.4. For index 1, we change it to 2.4.2. Just a little bit of difference for us to understand that. Then you have path hold model. Then you have the shadowing model. You have different parameters which can be set accordingly. Then you do apply and then OK if you want it. And then going to the mobility part, it is used to define the mobility strategies for the nodes in the scenario. That can be set only when there are nodes in the scenario. So if you have placed any nodes, this will come automatically, then you can change them here. Then you have statistics and file. It is used for configuring the parameters to collect the statistics and the packet traces of the scenario level. So first, let's go out with the file statistics. This has the parameters for enabling for different layers and models at the scenario level. So at the scenario level, if you want to change anything like the IP input, scheduler, task and queue, you can just check them and uncheck them as required. Then you have your packet tracer. In packet tracer, you can enable the packet tracer, disable the packet tracers. Then you have your statistic databases. It is used for configuring the statistic database part. Set yes, you have the few other parameters which you have to set accordingly. Then you have the supplementary files. These supplemental files are used for modeling the scenarios. It's all optional. If required, you can change them, but it's not necessary. Then you have the external interface. These external interfaces are used once if you want to attach an external interface for the scenarios. You have the AGI interface. It's called the AGI Satellite Toolkit interface. For that. Then you have your socket interface. It is for the socket interface. Then you have the VR link that is used for configuring HLA and DIS. Then you have the DIS parameters. Then you have the HLA interfaces. Accordingly, you can check and uncheck them for enabling it. Then you apply. Okay, this is about the scenario properties. Then let's open that recently used file. Here you have your parameters. Let me open one of the default parameters. Right click properties, you get them. Okay, in general you have node name, 2D icon, 3D icon and everything. In the 2D icon, it's basically how the icon will look in the XY plane, just the plane diagram. So if you want to change it to 3D, it should look like a 3D icon. Then you have the scale factor, then you have the partition. Then going to node configurations, you have your mobility and placement. That is for the mobility given to that particular node. It can be either group mobility or the random waypoint accordingly. Then using the altitude for terrain file, you can use it. You have to set it again. Then you have your specific node orientation. Then going to the network level, you have different networks here. You have IPv4, IPv6, GSM layer 3, dual IP cellular. You can set anything, but basically IPv4 is the one which is used in all the scenarios, so let's skip that. Then you have the routing protocol. In routing protocol, you have different routing protocols like the Bellman 4, the DSR, the DIMO, all that. All this is used according to the scenario, but for the wireless networks, it is only Bellman AODV, Bellman 4, which is used. Then you have your enabling IP forwarding packets, yes, no. See, all these are set according to the protocol which is used for the scenario. So that can be set. Then you have your enabling multicast and all that. Then you have your routing properties. In routing properties, type of routers are usually predefined, but if you want it user defined, you have to set a path given. Then you have your specific router parameters and configuration file. Then you have your transport layer, which has the enable RSVP, yes, no. You can set them as required. This is maximum segment size and buffer size. Then you have your receive buffering, sending buffering, then enabling the TCP packets. All that can be set and reset according to the scenario. Then you have application layer, then you have a behavior model, then you have a battery model. Battery model and all set to know whatever battery is being used, how much residual left estimator, all that can be done accordingly. So if you put linear model, it asks for battery change monitoring level at what seconds, at every 60 seconds or every 70 seconds. This can be set. Then you have full battery capacity, mAh is 1002. This also can be changed according to the scenario. Then you have external interfaces, you have false and all that. In interfaces, you have interface 0 and interface 1. In interface 0, you have your physical layer, MAC layer, network layer. MAC layer basically has the atomic default router, the MAC propagation delay, then you have your enabling promiscuous mode, then enabling LLC. All this is again set if you want to change the interface of the MAC layer. IPv4 packet, again as I said, IPv4 is what is used. Then you have your routing protocol, then false. Then this false can be added if you think that might be a scenario where it can occur. So you can add this, you can add the fault where it might start, where it might end, specifying whether it is a replacement card MAC address. So that is set only if you want, otherwise deleted it. Then you have your file interface, file statistics. That is again setting and desetting. This will have effect on the .config file later on, which will be shown to you. But this is again just left the way it is because we don't want to add extra parameters because the file becomes pretty huge later on. Same thing applies for the interface one also. So then apply OK. You'll get the device for this one. Then going to the switch icon, let us go with the general tab. It is the model name. Same thing, 2D icon, 3D icon is exactly the same. Then you have the scale factor. It's almost the same. There's nothing much difference. In switch, you have your general properties. In general properties, you have the run STP. Either you can set to yes or no mode. Then you have the interface. In the interface tab, this is used for configuring the interface properties such as the interface name, type, IP address, IP mask, and then the interface type, that is your faults that can be set accordingly for different interfaces. You have four interfaces here, so according to that everything can be set. Then you have your ports. This tab is actually available only when a switch is connected to a device, and it is used for configuring port level parameters like the STP. Let me open one. You have the STP here, which is for the spanning tree parameters, and VLAN for the virtual LAN parameters. So that is about the switch. Let's cancel that. Then you have your hub. In hub, you have tabs here. One's general routing properties, ARP, and file statistics. In general, you have a 2D icon, 3D icon. Then you have your scale factor, then MAC protocol, network protocol, enable fix protocol. All these protocols are extra for this wired subnet protocol. So next you have your routing protocol. In routing protocol, you have your Bellman-Ford AOD. This routing protocol can be Bellman-Ford AODV, as I told before. Then you have your IP forwarding, yes, no, all that can be set. Then you have your BGP configurations. In this, you have your BGP router ID, then the network advertising, the inverse, all that can be set. Then routing properties, again, as I said, it should be predefined or use-defined accordingly. Then you have the ARP. Enabling the ARP gives you few more parameters which can be set. That is the number of buffer entries, then the ARP timeout interval, then the ARP statistic cache file. This all can be set accordingly. Then you have your file statistics. These, again, as I said before, can be checked and unchecked if necessary, only if you want the things in the .config file to be set. Then you can do apply, then you can go ahead. Then you have your ATM devices. Coming to ATM devices, the general properties are the same. You have your 2D icon, 3D icon, scale factor, node type. Node type over here for ATM can be a switch or can be an end system. If an end system, you need to set it from the user side. Then you have your ATM static routers and your partitions. Then coming to the node configuration, you have the mobility for the nodes. Then you have the network layer. Then you have your routing protocol, then the routing properties, then the transport layer. All this can be set only if you want to change the ATM devices proper properties. Then you have your file statistics. You have your ATM level layer 2 statistics, enabling and disabling them. Then you have your scheduler statistics, whether you can enable or disable them. When you're enabling them, there's one icon which appears on the right, which tries to tell that the default value of this has been changed. So pressing on that comes back with a default value. Then you have your adaptation protocol. That is again having few parameters here as the ATM connection refresh time, ATM connection timeout time, then signaling statistics, adapting layer statistics. All that can be set accordingly. Then you have your ATM interface. This ATM interfaces have different, like ATM layer 2, which has few properties which can be set. That is the threshold, the probability, the small packet transmission time, the scheduler statistics, number of queues you want. That can be set again by adding indexes and then minusing them and then adding the queue size as a required. Then you have your adaptation protocol, which has the refresh time, the timeout time, the signaling statistics, all that can be set. Then you have the ARP, enabling and disabling them. This is about the ATM devices. Then this is wireless. Let's come to the wireless. Wireless is basically telling that the Wi-Fi is also wireless. So setting for that is what we are going to do now. Here the same general properties are the same like the 2D, 3D scale factor. Then you have the physical layer, which tells the listenable and listening channels. In scenario properties, we had made two channels. One as a 2.4 as a channel frequency, one more was 2.4.2. So for those two channels is what we are using the listenable and listening channels. Listenable channel is basically telling that what all it can listen to. You know, you can listen to 3-4 people at the same time if the pitch is different. And listening channel is what you want to listen to. So your frequency above that is 2.42. So you're setting that to channel 0 by the array editors. Then you have your radio type, it is 11.11b. And then you have others also dependingly. Then you have enabling auto rate fallback, then either the transmission sensitivity, receiving sensitivity, transmission power, receiving sensitivity can be set accordingly the way you want. Then you have a packet reception model, then you have the antenna model, then you have your antenna efficiency, the mismatch loss. Then coming to the MAC layer, the MAC protocol is actually the same radio type as what is being mentioned here for your radio type of the physical layer. So it has to be same, otherwise it gives an error. So then you have your short packet transmit limit, then the long packet transmit limit, then the station association type. If you set this to dynamic, you get your set as access point. So this wireless also can be set to an access point, but right now that's not required. We can just leave it like that. So you go to none here. Then you have your network layer. It has the same thing. Nothing much difference in this, just a few because it is wireless. Here in fixed communications, you have a packet drop probability and a specific packet delay. In packet drop probability, it's just trying to tell what is the probability you will give for dropping the packet. So you give 0.0 so that you don't want any packet to be dropped when there is a transmission. And then specific packet delay. If you really want some packet to be delivered in a later time, then you set this to yes with changing a few parameters telling how many seconds you want it to be delayed for. It's set to no use. Then you have a routing protocol, same thing, you can change this to whatever you want, whichever protocol is required for the scenario, and then accordingly these will be changed. And then you have your routing properties as same, file statistics as the same. Then you do apply and then OK for it to be set. Then coming to the links, let's start with the wired link. This has a property. This is called a point-to-point link because it's attaching to devices. You have a general properties like the link is wired. It has a MAC protocol as abstract link MAC, then you have your symmetric as yes, then you have your network protocol, which is the IPv4 cellular dual, then IPv6 all, but IPv4 is what is used. Then the addresses are set accordingly. The fragment unit is always 0.2048. Then you have your routing protocol, which is Bellman 4, that I've not changed anywhere. Then you have ARP, then you have your faults, then you have your background traffic. You can set your background traffic. When you're setting your background traffic, the source interface address is given. You can set, but it is given. The wireless sensor network as taken for one. It's that itself. Then you have your start time distribution. Then you have your duration distribution, bandwidth distribution, priority. All this is set only if you want a background traffic. Otherwise, it can be deselected. Then you have your file statistics. Same thing, and then you can click OK for it. Okay, let me start off with devices. As you've seen, the devices have been set. UTM devices again can be set like this. Then you have the application. You have your CBR, cellular, FTP, FTP gen. CBR from here can be taken from node 13 to node 5. That is to tell the packets from 13 to 5 has to be sent. It will go via the satellite and the wireless itself. Let's go to the CBR properties. You have a source from where to which node, destination. Items to send is usually set to 0. Then items end time is usually set to 0 again. All this will be shown in detail later on to you. Then you have your dynamic address application. This is the CBR from that. Then you have a single host, that's the HTTP, PD. Then you have links. You have your normal link and then you have your BGP linked. Then you have your hub. Then you have a wireless networks. Let me open another scenario to show the weather properties. The weather properties start off by you drawing a polygon. This is to show that a polygon is drawn where you want your particular set of a terrain to be having a weather scenario. So right click properties. This is the weather properties. You have weather 0, you've given a height as 1000, intensity as 0, you can change that to 20 if you want. Then the polarity is either vertical or horizontal. Then you enable the mobility for it by checking it. After checking it, you add mobilities you want. Let me add two mobilities. One as 20 and the second one as 30. 1 second. And then apply OK. You get two waypoints. One is at the starting point here, one is at the ending point here. So you can actually change wherever you want to show that that area is going to be under the weather conditions. Then okay, let me start off with few more things here. Device model editor. You have your different devices here. You can actually change them if you want to. You can add more if you want to. You can delete that if you don't want. So all this can be done if you want to customize the one what is here. Then you have your hierarchy model editor. And hierarchy model editor, one is already been as unnamed. You can add extra. Having an hierarchy, you can actually the name is given, you can give the icon specified, the background image if you want, and then the contents can be added. In the model type there are various here like the GCM, the satellite device, the human, node, sensors, ship, everything can be set accordingly with the placement as row, random, file, grid, anything can be set. If you put a file, they'll ask you where the file is, you can set accordingly. That is set, otherwise not required. You can clear the table, you can clear the existing scenarios also. Yeah, clear. So that is about it. Then you have your toolset editor. In toolset editor, this is the toolset, so you can add devices to this again. See, supposedly you want to customize it. You can select the tool target like the devices, the UGM applications, which has already been present here. Let's take the device. Here you already have a device, you have a hub, you have a ATM, you have a ground station, you have a satellite, you have a human. So something else you want to add, like the ship. So you select the ship, you use the greater sign, which means that the ship is being added. So you do apply, then okay, a ship is being set here. You can you can select it, drag and drop it here, means a ship is being selected. But sometimes not always you require that. So to take that back, you can go back to the tool editor, customize, you can go back to the ship, and then you can undo it. So this is not requiredly done for devices to devices. It can be done from any category to any category. So whatever is sent here can be sent here to change the settings to show what you want is required. Then you apply OK, it will get updated there for you.
Hello, this is Misbah from MSIT. Now we will be learning how to create simple scenarios and understand its working. In this section, we will be learning how to model the networks in QualNet. Modeling of networks is nothing but creating your own scenarios on the QualNet canvas. Now, a scenario consists of the following files. First, we have the .config file. The .config file is nothing but the configuration file, which has all the parameters like your type of routing protocol used, the application layer properties, etc. And next, we have the .nodes file. The .nodes file has all the initial node positions. Once the node position has been changed in the QualNet canvas, the same thing is reflected in the .nodes file. And then we have the .app file. The .app file is nothing but your application file. All the various kinds of applications used in your QualNet scenario have been reflected here. The various properties for the individual applications are shown. And then we have the .display file. In the .display file, what all should be available on your QualNet screen for the GUI part is present. And then we have the .stat file. In the .stat file, it is nothing but an output file which consists of all the statistics present. The various statistics that need to be analyzed are present in this. Now let's move on to the QualNet GUI. Let's go to the scenario properties and name our experiment as QualNet 1. And let's change our simulation time to 101 for convenience. Let's then change the terrain size to 1000 cross 1000 on the x and y axis using the Cartesian coordinates. You can even choose the longitude and latitude mode and then click on apply and then OK. Once we get the canvas of 1000 cross 1000, let's create 3 scenarios. First the wired, and then the wireless, and then the sensor networks. For the wired, let's place certain number of nodes, 1, 2, 3 and 4. And let's just connect these nodes using a link. So on the left panel, click on the link, click on node number 1, drag and leave on node number 2. So that creates a link from node number 1 to node number 2. The same thing is repeated for all the nodes. Let's create a square network. Once this is done, let's have a CBR application from node number 1 to node number 3. Now we will modify the CBR properties. So right click on CBR, properties, and items to send is set to 0. The item size can be anything because it's wired, and then end time is again set to 0. We click on apply and then OK. The previous thing was done because the items to send should be sending till the simulation ends. Now we'll go to the table view. Right click on any node and we can go to the properties of that individual node, or we can either do Ctrl L or click on select all. Once this is done, we can go to right click and then again properties, and then the node configuration. The type of routing protocol can be clicked on the left, so Bellman Ford is used. So we click on OK and we minimize the table view. Once this is done, we should save our scenario in any folder required. So let's save it, call it as G1. So save. Once this is saved, there's this icon called run simulation. You can click on run simulation and you get a left panel which has various parameters like animation speed, progress, the event filters. So animation speed can be decreased or increased. The event filters can be enabled, whichever you want, and then it can also be disabled. So let's play our scenario. So this is how it is played. And again, let's run our simulation and go in the step mode, which says that how the data has been sent in a step-by-step manner. Once this is sent, you can see that the data from node number 1 to node number 3 goes via node 2. So again, if at all a scenario requires blocking of node 2, then we right click on that particular node while running a scenario and click on deactivate node. This node has been deactivated. Now when we continue our step mode, then we can see that the data which was being sent from node number 2 is being shifted to node number 4. So the data goes from 1 to 4 and then to 3. The same thing can be played together. Now let's analyze a scenario. Now we'll have the CBR client and we'll click on total unicast messages sent, and then the total messages metric value says that it's 100. Now we'll go to CBR server and see how many packets have been received. Since we have blocked it, only 30 packets have been received. This is how you analyze the CallNet. Now let's go to the architect mode and create one more scenario, and by changing the scenario properties and renaming the experiment as CallNet 2 and changing the simulation time again as 101 and changing the terrain as 100 cross 100 or 300 cross 300 because it's a wireless network. So we click on apply and then OK. Now once we get our terrain, we place certain number of nodes on the canvas at various locations, and then using the lasso tool present over here, we click on the lasso tool and select which all nodes required for our wireless network, and then we click on this icon called wireless network and then we place it over here. So all the nodes are connected to this. Now we modify the wireless network properties and take the physical layer as 802.11b. The same thing should be present in MAC. The network layer, routing protocol is Bellman 4. Let's use AODV. And the router properties should be predefined. We click on apply and then OK. Now let's have a CBR connection from node number 1 to node number 3. Now we modify the CBR properties over here, right click properties, and then the items to be sent is 0. The item size is kept small because it's wireless. The end time is again set to 0. The item size was set to 50. Then we click on apply and then OK. Now once this is done, we go to the table view and right click on the properties of all the nodes. So again go to properties and the node configuration, the routing protocol is Bellman 4. We select AODV and then we click on apply and then OK. Minimize the table view. Now we save our scenario. Let's call it as G2. And then we run a simulation. We can do this either using the step-by-step mode. Here the data has been broadcasted and the packet has been sent from 1 to 3. Or you can directly play it. And then we click on the analyze statistics of current scenario. Here we have a CBR client and server. The total unicast messages sent can be clicked. You can see that the node number 1 is sending the message. So the total unicast messages sent is 100. When we go to the CBR server, node number 3 is the server who has received the data and the messages received is 100. Since there is no blockage, all the data has been sent. Now let's go to the architect mode. In the architect mode, let's create one more scenario. Here, in this, we will create a sensor network scenario. So modifying the scenario properties again, naming it as CallNet 3. And the simulation time is again set to 101. And the terrain is 100 cross 100 in the Cartesian coordinate system. Once we click on apply and then OK, we get a terrain of 100 cross 100 in the X and Y axis. Now let's place certain number of nodes, the 3 normal nodes, node 1, 2, 3. The 4th node is the coordinator and the fifth node is the PAN coordinator. Let's select all the nodes using the lasso tool. Once we select all the nodes, we click on the wireless network and place it on the canvas. So all the nodes get automatically connected to the wireless network. So we modify the wireless network properties, right click properties, and then we go to the physical layer. Since it is sensor networks, we select 802.15.4 radio as the radio type. The same thing should be updated in the MAC. In the routing protocol, AODV is used, and the router properties is predefined. The antenna model for sensor network should be omnidirectional. So we click on apply and then OK. Now we can see that this node going to the MAC layer is an RFD by default because the wireless network was set. Now we want to modify node number 4 to a coordinator. So we go to right click and then properties, and then we go to interfaces, scroll down, MAC layer, change the device type to FFD and change the FFD mode to coordinator. Then we click on apply and then OK. And then we do the same thing for node number 5 but change it to a PAN coordinator. So right click properties and then interfaces. We go to the MAC layer. It is an RFD, so change it to an FFD, and the FFD mode should be PAN coordinator. So we click on apply and then OK. So 1, 2, 3 are the normal nodes, 4 is the coordinator and 5 is the PAN coordinator. Now we'll have a CBR connection from node number 1 to node number 2. Similarly, modifying the CBR properties, right click properties on the CBR. The item to send is set to 0. The item size should be small because it's wireless. And the end time is again set to 0. We click on apply and then OK. We just check that the scenario simulation time is 101. Now once this is done, we save it as G3. We run the simulation. You can see that node number 1 is talking to node number 5, which is PAN coordinator. And the same thing, the PAN coordinator is forwarding the data received from node number 1 to node number 2. So the PAN coordinator is the intermediator here. So using it, the data has been sent from node number 1 to node number 2. So we can finish playing it and then we can go to the analyzer part. And here in the CBR client, we'll just see how many messages were sent. The total messages sent were by just placing your mouse on the purple bar. You can see that the metric value is 100. The same thing for CBR server. Here again, by placing your mouse on the purple bar, the metric value is 98. So out of 100, 98 packets were received by node number 2.
Everyone, I am Praveen from MSRIT. Hope you guys understood with the creation of the scenario and the QualNet. Let's continue with the analyzation part of the scenario, and the QualNet has a poll.
Let's simulate the scenario, run it and analyze the scenario. So here we can see the 4 component tools. So let's analyze each and every component in detail. So now let's analyze this analyzer tool. So what analyzer tool? Analyzer is a graphical tool for analyzing the statistics generated by the simulation. So when a simulator is run from the command line or from architect, a statistic file, that is .stat files, are created that can be used for analyzing the simulation results. So it parses the contents of the statistics file and present the information graphically, can be shown later. So this provides the convenient way to analyze the simulation results. So now we can see this is the standard toolbar to open the files and to close those files. This is the histogram bin size bar, and this is the view toolbar, and this is the left panel. In left panel we have file system. These are the file folders that can be make use to open the files that are required for the scenarios. So this is the statistics file. So this is the statistics files has many layers like application layer, transport layer, network, MAC, physical, and etc. So let us analyze each and every layer in detail. So in case of application layer, we have CBR client and the CBR server. So in CBR client, we can analyze the packets for unicast session, for unicast fragment sent and received. Let's analyze the unicast messages sent. So this is the node number 2, which is the source node of metric value 10. Now CBR server, it is the receiving node So let's consider total uniquest messages received. So here the metric value 97. So there is the difference of 3 packets. So now, so where those packets are dropping or delaying can be analyzed in future coming layers. Like we have in transport layer, we have the protocols like TCP and the UDP, and in TCP we have data packets in sequence retransmitted, and that acknowledgement packet received and sent, and the packets received with the checksum can be analyzed, and the throughput and the delay can be analyzed in case of transport layer. So now network layer, in network layer we have the protocols like IP and AODV, etc., and it can be each and every protocol provides some unique data that can be analyzed. So for data packets received with the broadcast and control packets received, and these can be analyzed similarly for AODV. So this is the concerned protocol for the scenario AODV that we have used. So the number of the root request packets, root error packets, and something etc. Can be analyzed. And MAC layer, in case of MAC layer we can analyze the dropping of the packets and packets sent, received and forwarded by the nodes. So if you have the PAN coordinator and coordinators that does the forwarding things and all. So now this is the number of data packets dropped due to channel access failure that can be analyzed for each and every node. And in case of physical layer, this is the radio type. So 802.15.4 for sensor networks, signal transmitted, detected and received and forwarded to MAC layer can be analyzed, similar for SSCS. So this is the file list. These are the files that are recently opened for the concerned scenario only. So, and this is the bottom panel. This is the overview of the graph, and this is the static file. This is the text file that is generated once we are done with the execution of the scenario, and this is the error log to isolate the errors during the passing of the packets. And thus this is the bottom panel. So now we'll move on to packet tracer. Now packet tracer, it is a module of the QualNet GUI that provides a visual representation allowing you to analyze the information contained in the trace files. Though those files are have the extension of or dot trace, which are in XML format, and that contain the information about the movement of the packets up and down the protocol stack, can be analyzed later. So it provides mainly the search, sort and filter functionality for meaningful and efficient results. So now let's this is the standard toolbar. This is the reload in order to load the scenario once again. So this is the file system. These are the folders can be make use to retrieve the concerned file. So now the file will open the recent file dot trace file. So this is the dot trace file and it consists of the many data records, and it can be viewed as the data record table. So it has attributes like index, type of the packet sent, and the mark. It indicates the status of the record that has been selected or not, this thing. And tracing node, the nodes that can be traced, and tracing protocol, protocols which are tracing the nodes and packets and all, and simulation tile to display the time and to set the times and all. For originating node, the node from which the packets have been originated and message sequence and etc. can be analyzed. Similarly we have action. This is the action type. So action type we have many actions like NQ, DQ, drop and send request. And dropping, it displays the concerned reason. For NQ and the DQ, it gives the queue ID and the queue priorities like this. Queue info, queue ID, queue priority for the concerned records, for the records of the data record panel. And this is the protocol header. Protocol header, it displays the header data of a trace record, and this is the actually the format of the protocol header. So it has the version, header length and total length identification, and the flags and checksum, TTL, time to leave, total time to leave, and source IP, destination IP, and these things can be analyzed for concerned trace files. Now this is the protocol explorer. It is basically, it displays the list of the protocols that are required and present in the trace files. So this is the protocol. It has attribute name and the type of the attributes. And similarly if we consider this AODV, it has the root request protocol, the type of the attribute, and this type of the attribute, similarly RREP, RREQ. And now you will see what find record. So this is the find record. We can get the file recent files, the trace. Okay, it's already opened. Now this is the rule editor. Actually this is the find record. It is the move up, move down, new file, uh, edit the file, delete the file, and remove all the files and find the next record, these things. So this is the new rule editor. So rule editor, we can edit the rules and we can filter the, basically it is going to filter the records in the data record panel for the concerned nodes and all. So this is the record header. So in record header, let's see what originating node will be. So if you consider now originating node, so this is the condition, search condition. So search condition for the originating nodes will be list. List here because a list of the nodes that are present in the scenario can be filtered and searched for the results. So we can, and it displays the two choice boxes, and this is the all choices and this is the selected choices. These are the nodes that are present in the concerned scenario. We can filter data of the nodes that are required. So if I need the data to be filtered for node 2, I'll do this. So this node 2 is present, moved to the selected choices, so that data of that node can be filtered. And similarly we can reverse back the node 2 here, and similarly we can move all the nodes to if you want to filter all the data of all the nodes, can be done like this and reverse back like this. And thus now I'll consider 3. So now I'll click on OK. So now this is about after search condition. So it displays this text message like key header originating node, and condition that I have considered here is selection list. So the value range of selection list, it displays this node. So now we'll pass on to filter queue editor. So now filter queue editor, it provides the advanced filtering and searching functions and various parameters of the data. So now I'll consider the file recent files. Oh, actually this is the open file. So now on filter editor, so I'll consider record header similarly. So for simulation time and the message sequence number equal to, I'll consider now range. For simulation time we need the range actually. So starting time and the ending time, so it will ask for minimum value. Minimum value I'll take it as 2, and maximum value I'll take it as 5. And this is the navigation toolbar. I already informed you regarding this. So this is the next record. If I click on this, it will go for the next record. So if we click on this, it will moves the control to the first record, and this is for a last record. And we have here the bottom panel. In bottom panel we have the file properties. So file properties is categorized into 3 groups, like file information, it gives the information about the file like name, path and size, and trace meta file, this is the version and the scenario that I created, and etc. In protocol ID map, it has it displays the protocol list of the protocols and the protocol names present in the trace files. And thus about the packet tracer. Now we pass on to the file editor. So file editor, it is a text editing tool that can be used for viewing and editing the files associated with the scenario file. So now this is the standard toolbar already, you know, to open the files, to close the files, and to save the files, and this is to print the concerned files. So this is the file system. So already I have explained regarding this. We can add the new files by clicking on this and can be done. So time being we'll pass on to file list. So this is the recent file that have been opened. So I'll open this .config file, and this is the .configuration file. So what actually this configuration file is, once we are done with the creation of the scenario in the design part, so this is the architect part, after execution of it, it is going to create the text editing file, nothing but .configuration file. So thus it is the scenario configuration file. So actually general settings and parallel settings we have seen in case of advanced settings and terrain, type of the terrain that we needed, and etc. This is the statistics file. And yes, So in case of file editor, we can observe here, in case of statistics, we have physical layer statistics, MAC layer and everything. These are nothing but the parameter names and the yes, no, and these are the value options. And similarly, we have packet tracing, and this is the interfaces. If at all we are connecting any hardware components to the simulation part and analyzing, so we will make use of these interfaces and can be analyzed. So now in case of physical layer, this is the physical layer, MAC layer, and those are all configured things, and network layer, and ash indicate this is the comments in case of the editing tools. And in case of MAC layer, where is that MAC layer? Yeah, MAC layer, we have the IP address node 8 for concerned nodes. MAC address within the square brackets indicate they are the qualifiers, and 15.4 no, yes, these things are nothing but the values. So and thus we have one more bottom panel. Now this is nothing but the find panel. It is used to find the text strings in the active file, for this file, and can be edited. So now I'll give something like seed, and I'll search for it. So seed, it is going to highlight the seed part and can be edited if at all we need it. So right now we don't want to edit anything, so similarly we can editing in this file .configuration file, not only for configuration file, for stat file and .anim file can be configured.
Let's see the overview of QualNet. It comprises of the following phases. The first phase is to create and prepare the simulation scenario based on the system description and metrics of interest. The next step is to execute, visualize and analyze the created scenario and collect the simulation results. So simulation results can handle scenario animations, runtime statistics, final statistics and output traces, that is .trace, .stat files and all. So finally the last step is to analyze the simulation results. So typically users may need to adjust the scenarios based on the collected simulation results.